Wind is cheaper than oil, and the most cost-effective source of energy in the high seas. Yet this attractive savings potential is not being exploited anymore because conventional sailing systems can no longer satisfy the needs of modern maritime shipping. SkySails now offers a towing kite wind propulsion system that fulfills all requirements. By using the SkySails system, a ship's annual average fuel cost can be reduced by between 10 and 35%, depending on wind conditions. Under optimal conditions, fuel consumption can at times even be reduced up to 50%. Its economical procurement and operation costs means that SkySails systems will usually amortize itself within 3 to 5 years. A towing kite similar to a paraglider replaces traditional sails and masts. The SkySails towing kite usually flies in figures ahead of the ship, such as figure eights. Doing so artificially increases the wind speed on the kite's profile. This allows the SkySails to easily achieve 5 times the propulsion force compared to standard sails. Thus, tremendous savings can be achieved despite the towing kite's relatively small size. For comparison, the 109-meter-long 4-mast bark Sea Cloud has a total of 3,000 square meters of canvas under full sail. A modern cargo ship of the same length would be optimally equipped by a 300 square meter size auxiliary SkySail propulsion system. SkySails fly at an altitude of 100 to 300 meters, where stronger and more stable winds prevail. The aerodynamic properties of the SkySail towing kite double wall profile are compared to those of the wings of an airplane. The SkySail system can not only be used on courses with winds from astern, but also on courses of up to a 50-degree angle against the wind. In practice, good propulsion values can be attained at 70 degrees or higher. Best performance is achieved on courses between 120 and 140 degrees. When folded, the textile towing kite is easy to stow and takes up very little space on board. A folded 160 square meter SkySails, for example, is only about the size of a telephone booth. The SkySails system has no disturbing superstructures that could impair loading and offloading of operations in port or passing under bridges. The towing kite is recovered and stored as the vessel nears the coast. Compared to conventional wind propulsion, the minimal heel caused by the SkySails system is insignificant in terms of the ship's safety and operations. The reason for this is that the force of the SkySails towing kite is passed directly into the ship's structure at deck level. This shortens the lever arm, which causes the heeling so typical of sailing ships. Depending on wind force, the SkySails towing kite angle of attack is varied in relation to the horizon. The dynamic winch control releases and retracts the towing rope as needed. The feature ensures not only complete power control, but that the same towing kite can be used for all wind intensities. Within a maximum of 30 seconds, the autopilot can fly the towing kite into the neutral zenith position directly above the ship, should strong winds suddenly appear. The towing kite exerts only a very minor force on the ship in this position, thereby allowing it to be safely recovered even in strong winds. The SkySails system consists of 3 simple main components: a towing kite with rope, a launch and recovery system, and an automatic control system. The towing kite is made of high-strength and weatherproof textiles. It has a double wall construction with chambers along its entire length and openings on its front. A coupling mechanism connects the towing kite with the launch and recovery mast. The towing kites currently available from SkySails are approximately 150 to 600 square meters in size. The kite's tractive forces are transmitted to the ship over a high tear-proof synthetic fiber rope that is more stable and vastly lighter than a comparable steel cable. The force transmission point, also known as the tow point, is installed on the forecastle. Here, the existing ship structures are normally sufficiently strong, since this is also where the anchor windlass is housed. Thus, high tractive forces can easily be transmitted to the ship at this point. A dynamically operating winch releases and recovers the SkySails towing kite. The rope is also stored on this winch. The winch's operating speed is calculated so that the towing kite can be stabilized and safely recovered during a sudden calm. The launch and recovery system consists of a telescopic mast with a coupling mechanism for the towing kite. A reefing system unfurls and reefs the kite respectively during the launch and recovery process. The kite is stored in the towing kite compartment on the forecastle. The steering system for the SkySails propulsion works automatically. It aligns the towing kite to provide optimal propulsion depending on the direction and strength of the wind, as well as the ship's course and speed. The SkySails steering system consists of a control pod and the control system. The control pod's function is comparable to that of a paraglider pilot. It shortens or lengthens the control line on the right or left, so influencing the flight path of the towing kite. The control pod is supplied with data and energy through a special cable integrated within the towing rope. The function of the control system is to steer the SkySails system automatically. It is similar to the autopilot of an aircraft. A graphic user interface on the bridge keeps the ship's officer informed about the system's condition and allows them to operate the system by inputting commands. The control of the launch and recovery procedures can be operated from a control panel installed on the forecastle. SkySails propulsion is employed on the open seas. The SkySails system can be utilized at wind strengths of between 3 and 8 Beaufort. During launch, a telescopic mast raises the towing kite from its storage container. The kite is folded like an accordion. It then unfolds to its full size and can be launched once the launch and recovery mast is fully extended. A winch is used to release the towing rope until operating altitude has been reached. The SkySails system can be operated from the bridge. The SkySails propulsion's automatic control system takes control of the towing kite and its flight path. The crew is kept constantly informed about the system's operation status on a display screen. The ship's officer can see on the SkySails user interface display the spectrum of courses along which the SkySails system can be operated, and to what extent the main engine's power can be reduced. The SkySails system compensates for brief fluctuations in tractive force. All ship maneuvers can be undertaken while operating under SkySails. This is because the towing kite can be positioned in a force-neutral zenith position above the ship at the push of a button as needed. The active main winch is capable of compensating for sudden gales or weakening winds. The recovery process is done in the reverse order of the launch. The winch retracts the towing rope and docks the towing kite on the launch and recovery mast. The towing kite is then reefed. The telescopic mast retracts and the towing kite is stowed in its storage container along with the control pod. The launch and recovery procedures of the towing kite each take about 10 to 20 minutes. SkySails propulsion is so compact and universal that it can be installed or retrofitted on most ocean-going cargo ships. The vast majority of the SkySails system components, the winch and the SkySails arrangement module, are installed on the forecastle. The SkySails system is connected to the ship's electrical and/or hydraulic system at the forecastle. The SkySails workstation for operating the systems is installed on the bridge. Installation can be made at any port that has a crane system and without the ship having to be placed in dry dock. The system is installed by the shipyard of the customer's choice under the supervision of experienced SkySails engineers. Components are installed in 3 steps, which can be performed independently of each other and at different times and locations as needed. This, for example, allows using extended docking times for loading and offloading to install the SkySails system. The first installation step is preparing the foundation for the SkySails arrangement module and the winch, and cutting the openings for cables and hydraulic lines. The foredeck may require reinforcement. The ship's structure in this area is often stable enough, since this is where the anchor windlass is housed. The second installation step is when the components, the SkySails arrangement module, SAM, and the winch are installed on the forecastle. This step also includes installing the SkySails workstation for operating the system on the bridge. Then, in the third step, the electrical and hydraulic lines are laid and the system components are connected. The towing rope is spooled onto the winch, and the towing kite and control pod are stowed. The functions of all the components are tested once the installation has been completed. The SkySails system itself is tested during sea trials. Classification societies have classified the SkySails system as an auxiliary propulsion system. The system, as operated today, does not conflict with any regulations. All components of the SkySails system, except towing kite, towing rope, and steering system, can be serviced by technically qualified staff. These services can be carried out offshore when the SkySails system is not in use. System components requiring specific know-how are serviced by SkySails specialists. If required, they can be requested at any harbor in the world. SkySails offer shipping companies custom training and instruction to optimally prepare their crews for using the SkySails system efficiently and safely. The training program comprises both theoretical instruction and hands-on training. SkySails operates with an excellent network of renowned development partners and suppliers. The SkySails system is a successful combination of proprietary development, as well as tried and tested components from both aviation and the shipping industry. An example of this is the application of modified mooring winches from the offshore industry.